I've already mentioned the concept of scope several times in this course, and I'll be mentioning scope again later on, so it's worth taking some time to clarify exactly what scope means and why it's important. If you load up the Trek sample program, you'll find this program, which is based on the idea taken from Star Trek, where the crew members can go into a holodeck, that's a virtual world, and when they're on the holodeck they have access to virtual objects which only exist in the holodeck. And so I'm using this to explain scoping of variables. Now let's see how this works. Here's my form. It has two buttons, go to holodeck, go to bridge. The form create event is listed over here in the events panel, and I've created, by double clicking it, a form create event handler, and that sets real weapon to the string phaser gun. Now what is real weapon? Real weapon is a variable that I've declared up in the top var section, right at the top of my unit, just above the implementation keyword. Now when I click go to holodeck, this button clears the memo and then it calls the go to holodeck procedure, and that's up here. And this displays some information about the holodeck, but the important thing is it displays the string assigned to the two variables holoweapon and real weapon. Real weapon we already know, that's been declared up in the top var section of the unit. So where's holoweapon declared? Well, holoweapon is declared in the go to holodeck procedure. That's the procedure that I am in at the moment. So this procedure has access to the local variable, that's the variable declared in the procedure itself, and it has access to the unit level variable. You can think of it as a global variable. It's globally available to all the procedures in this current code unit, and that's the real weapon variable. Let's look back on the form, go to bridge. Go to bridge, that calls the go to bridge procedure, and that again displays some string information, and it displays real weapon. That's, remember, the variable declared up here. So both those procedures have access to the variable up here, the unit level variable, but only the holodeck, go to holodeck procedure has access to holoweapon. So let's run this to see it. So it builds, pops up, and I click go to holodeck. Displays the description of the holodeck, and it says I've got my holoweapon, and it gives the string that I've assigned to holoweapon, which is in this local procedure. So look again at the code so you can see this. And it also displays the real weapon, and that's the code down here, and that's the weapon that I've initialized in the var section at the top of the unit. Go to bridge. Now I'm leaving the holodeck, so I no longer have access to my virtual weapon, the holoweapon. So go to bridge. Let's have a look at the code so you can compare it. So it displays the description of the bridge, and it shows I've got my real weapon, which is the phaser gun. Now you'll see I've commented out the line down here that says what the holoweapon is, and that's because the holoweapon does not exist in this context. It's not in the go to bridge procedure. So I can prove that by uncommenting and trying to run again, and there's an error. Identifier not found, holoweapon. So in summary, when I have a local variable, one that's declared in a procedure, it is available only in that procedure. And that's why I can access holoweapon in this procedure, but not in this procedure. When I declare a variable that is outside the procedures, but in the same unit, I can say that's globally available, or it's available at the unit level. And so real weapon, which is declared up above the two procedures, is available in all the procedures in this code unit. Now let's consider what happens if you have the same identifier that's a variable with the same name declared in multiple different places. Here's an example. This is the test vars project. At the unit level, I've declared I to be an integer. So I is available, as we know from the last project, I is available to all the procedures in this unit. But, as you can see down here, some of the procedures, button 1 click, button 2 click, also declare a local variable called I. So this is I local to button 1 click. It's not visible outside this procedure. This is I local to button 2 click. It's not visible outside the button 2 click procedure. Now, button 3 click does not declare a variable I, nor does test button click, but they both print the value of I. And button 3 click also sets the value of I. This leads to the question, when those procedures that have their own local variable I declared, if they set a value or display a value for I, which I are they using? Is it the unit level I declared up here, which, as we know, is visible to all procedures in the unit, or is it the local I that is declared in button 1 click and button 2 click? Well, let's run it and see what happens. And this is the form that pops up. So the first button is button 1 click, set I to 10. Before I do that, let's test I. So I has been, at the outset, in form create, set to 0. So when I click the test button, test I, what does it display? No surprises, it displays the unit level I, its value was set to 0. Now in button 1 click sets I to 10. So let's set I to 10. And it displays, indeed, it's been set to 10. So if I click test I again, test I, remember this procedure does not have a local variable I, so it will display the value of the unit level I. That's still 0. So button 1 click, even though it set I to 10, and it verified that I was set to 10 by printing it into the edit 1 text box, the global I, or the unit level I that I declared at the top of the unit, is still 0. It's been unaffected. So in button 1 click, the I that it is dealing with, the I to which it sets a value and which it displays, is its local variable I. Button 2 click is much the same as button 1 click. The only difference is it sets I to 20. And again it displays the value, so we know that it's set I to 20. But we can predict that this is again going to be its local I. So both button 1 click and button 2 click have their local variables called I. And when I test the global I, again it's been unchanged. Button 3 click is different. The code looks the same, or very similar to the code in button 1 click and button 2 click. The only difference is that button 3 click has not declared a variable I. That means that the only I to which it has access is this I, the one that's declared at the top of the unit. So when I click this button, what's happened to the global I, or the unit level I? It shows it's 30. So for button 1, it's 10, that's the local I. Button 2, it's 20, that's its local I. But button 3 has already set the unit level I to 30, so that's what I get here. So, in summary, the I that's declared locally in button 1 click and button 2 click is the one that is used when that identifier, when that name is used in any code in those procedures. It takes precedence over any outer I. So we have an inner scope, a local scope for those two procedures, and any variable with that name will be used in that inner scope instead of the outer scoped variable that's declared at the top. But when I have a procedure such as button 3-click, which has no local variable, then it has to go searching for the first variable it can find with that name. And the only one it can find here is the variable I declared up there. So take care when you use variables with the same name which are accessible within a shared scope. Bear in mind that any procedures with a variable of that name in their local scope will use that variable. Using variables with the same name in the same scope is, as a general principle, a bad idea, because it can be confusing, and by setting the wrong variable, the variable I don't intend, by setting its value to something, then that can have unpredictable consequences for the rest of the program. And finally, to consolidate your understanding of scope, take a look at the scope sample project. I'm not going to explain this in any detail here. I think it's better if you play around with it and see for yourself the effects of having local and global or unit level variables. So it's got a form with 5 buttons on. Let's have a look quickly at the code so you can see what you're looking for. Notice up here there are 3 strings that are declared at the level of this unit. So they're visible to all the procedures that follow it. And there are procedures that show the strings. Now, some of these procedures declare a local string. Now that variable name is not found up at the top. But look, it also declares ASTR, which is the same as this variable name. So consider the effects of accessing or assigning values to both the local string, the variable that has no equivalent here at the top, and the effect of assigning to this variable name, which does have an equivalent at the top. And the best thing is to run the program and examine the code while you're running it, so you can see the effects. So I'll just show you what you should be looking for. So, button 1 displays some strings, and you can compare the values of the strings with the variable names in the code. Button 2 does the same. Check when you're doing this, by the way, as to which variables display this local variable name and which have it commented out. Now, it's commented out here because the name does not occur in the scope of button 3-click. It only occurs in another procedure. So it's local to this procedure, it's not local to this procedure, and so I can't use that variable name. But I can use these 3 variable names because they've all been declared at the top. And so they are visible to all the procedures in this unit. So button 3-click, and you can see local str not found. I can't actually access that. Button 5-click. Now button 5 changes the values of the 3 globally declared variables. It has no local variables. So watch what happens when you subsequently try to display the values of variables with those names in the buttons, and check the results you get and compare them in those procedures that have their own local variables with the same names and those which do not. So, as I say, you should by now have enough knowledge of scope and how it works to make sense of this code, but it's worth playing around with, because getting a good, solid understanding of how scoping works is going to be a very useful skill when you go on to write complicated programs of your own.